Integer properties. In this module, we will talk about the integers. Of course, the integers are the positive and negative whole numbers. 1, 2, 3, 4, going on forever. Negative 1, negative 2, negative 3, negative 4, going on forever. And of course, that special number is 0. Those are the integers. In fact, most of what we will discuss in this module concerns the positive integers. The positive integers are the ordinary counting numbers, 1, 2, 3, 4, 5, 6, etc., going on forever. In this video, we're going to discuss a few interrelated ideas. These are mathematical terms you definitely need to know and understand for the test. The test will use these terms. And here are the three terms: factor, divisor, and divisible, and of course divisibility. Let's start by discussing these terms with formulas and some simple numerical examples. In all of these formulas, assume a, b, and c are positive integers. If we say that a times b equals c, then we can say that a and b are factors of c. In other words, we use them to multiply together to get c. To say that a is a factor of c is to say that we can multiply a by some positive integer and the product will equal c. So for example, 3 is a factor of 6. We can multiply 3 by an integer and get 6. 25 is a factor of 100. We can multiply 25 by a whole number, a positive integer, and get 100. Notice that 1 is a factor of every positive integer. Notice also that every positive integer is a factor of itself. Thus, every positive integer greater than 1 has at least two factors, 1 and itself. We'll return to that idea later. If c divided by a equals b, then we say that a is a divisor of c because it divides evenly into c. One number divides evenly into another when the quotient is an integer. We can also say that c is divisible by a. Notice there is absolutely no difference between factor and divisor. These two words mean exactly the same thing. In other words, the fact that something divides evenly into something precisely because you can multiply it by an integer and get that number. Thus, we have three interchangeable ways to say the same thing, and the test will use all three. 8 is a factor of 24, 8 is a divisor of 24, and 24 is divisible by 8. And once again, all those three, they really say the same mathematical fact. It's precisely because we can multiply 8 times 3 and get 24 that we can divide 8 into 24 and get 3. That's exactly the same mathematical piece of information. Similarly, 8 is not a factor of 12, 8 is not a divisor of 12, and 12 is not divisible by 8. Because the quotient, 12 over 8, is not an integer, and what amounts to the same thing, there is no positive integer b such that the product of 8 times b equals 12. This raises the very interesting question: what happens when we divide 12 by 8? There are two separate but perfectly correct mathematical procedures. Now, the first thing I want to say is that we divide two numbers evenly, then integer divided by integer equals integer. The quotient is an integer and that's it. There's not two options for this. That's just clear. There's just one way to do it: integer answer. But if the two items don't divide evenly, we have two possible options, each perfectly correct. Option number 1 have an integer quotient and an integer remainder. So for example, 8 goes into 12 once with a remainder of 4. So sometimes this is what we have to do: actually have the integer quotient and an integer remainder. Another option is to express the quotient as a fraction or a decimal. So for example, 12 over 8, that's an improper fraction. We simplify that to the improper fraction 3 over 2. We could express that also as the mixed numeral, 1.5. We could express this also as a decimal, 1.5. All of those are perfectly correct mathematically. You'll need to understand how to employ either option, but you will never have to decide which one to use. The nature of the test question will always make clear which one they mean. Either the test question is going to be asking about remainders, or it's going to give the answers in terms of fractions or decimals or something like that. So you'll always know exactly which option you have to pursue. We discussed changing between fractions and decimals in the arithmetic and fraction module in the video Conversions with Fractions and Decimals. So if you haven't seen that video yet, that would be a good video to see. That will clear up a lot of the questions you might have about handling option number 2, that option. In a later video in this module, we will discuss remainders at a greater level of sophistication. So right now we've just touched on the idea of remainders, but we have an entire lesson coming up on remainders. Now on another topic, notice that the number 36 has as factors the numbers 1, 2, 3, 4, 6, and 9, but the numbers 5, 7, and 8 are not factors of 36. Now this raises the interesting question, how would we find all the factors of 36? The easiest way is to list factor pairs, the pairs of numbers that have a product of 36. So what can we multiply together to get 36? Well, we can get 1 times 36, that equals 36. 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So we have 1, 2, 3, 4, 5, 6, 7, 8, and then the last one, 6, we don't count that twice, we only count that twice. We only count it once because we multiply it by itself. Notice that 36 has 9 factors, including 1 and itself. For small numbers, numbers less than 100, we can count the factors simply by making a list of factor pairs. We will learn another more efficient technique for larger numbers later in this module. Finally, a note about negative integers. Technically, it is true that both -4 and +4 are factors of -12. Both -4 and +4 are divisors of -12, and -12 is divisible by +4 and -4. So all that technically is true, but the test almost never asks about this or expects you to know it. So just keep it in the back of your mind. It could possibly show up maybe a 1/100th of 1% chance on a really, really hard question, but it's unlikely to show up at all. In summary, we talked about the interrelated ideas of factors, divisors, and divisibility. And it's very important to realize that the test will use these interchangeably. It's very important to recognize the connection between them. We talked about options for division that doesn't come out even, remainders versus non-integer quotients. And again, the non-integer quotients, you can go back and look at the fraction and decimal videos for more information on that. The information about remainders, that's coming in an upcoming module. We talked about listing the factors of the number by listing factor pairs and introduced the idea of counting factors. Again, that's something we're going to go into greater depth in a future video in this module. And finally, we talked about the seldom used rules for negative factors. Probably something you don't need to know at all, but we just mentioned it.